As you can probably tell, we are here at Automate in Detroit, Michigan. This is a very cool show for lots of reasons. Not only are there really cool technologies and lots of great people to connect with, but there are also different groups and types of people here. There are suppliers who are creating various automation components. There are integrators who are creating systems of various size and scale with all of these components. And then there are also end users who are the people who live with everything we're seeing at the show in their facilities, applied to their applications day in and day out. However, in this video, what I want to do is talk to some of the suppliers here at the show, and particularly some of the suppliers who are creating and developing some unique solutions here at the show. I'm at the Lexonics booth, and I have both Chenyuk and Jim with me here, and these guys are doing something pretty cool with AI and cameras. We're obviously seeing lots of cameras and just AI in general, but you guys are doing something pretty cool where you're building the AI into the camera in one unit and the computing there. So tell me a little bit about that and what you guys are doing.
Yeah, you described it pretty well. What we do is computer vision and AI on the edge, meaning that the computation actually happens on the device. And so what you get outside of the device is the actual result. So you are not necessarily looking for streaming the data out of the sensors, but you want to solve some problem, right? So let's say you want to detect an object, or you want to find 3D properties of a certain area. Let's say you want to find a floor or a box, and you want to measure the dimensions. So all that compute and the algorithms can run on the device while you are sending out only the final results, let's say the dimensions of that box.
Like what we've done is taken what can be a very complicated vision stack and compressed that onto a device, into a singular device. So we've fused a bunch of sensors and allowed you to do what Chenyuk has said, just stream only the results, only the most meaningful information off the device for use in a larger system.
For sure. Now, something I saw that was kind of unique about what I think you guys are doing is I saw thermal cameras, I saw standard vision, and I also heard maybe LiDAR. Is that true? And tell me a little bit about like how you're integrating these different sensors in your solutions.
Yeah, so again, like that goes into a whole sensor fusion discussion. So we have a time of flight sensor, which is getting pulled up, or actually that's not the time of flight. Oh no, it is. It is. The time of flight sensor, which is similar to LiDAR, have like IR dot projection and illumination, RGB cameras, we have thermal sensors, so a variety of different sensors, an IMU sensor for motion that all get fused together directly on the device. So again, you can take out the most meaningful pieces of information, not worry about how you put all that stuff together, use the data from that to output the result.
True. I mean, there are a lot of use cases in automation and robotics and all the areas, and people usually have different needs, and so we try to accommodate for that with different types of sensors. But what's also important is that if you combine multiple of those sensors in a single device, it has the added benefits of, let's say, being able to compensate the shortcomings of an individual sensor and having redundancy and improving the overall performance. So let's say you have an object detector on your RGB camera, which is a quite standard thing which people do. Let's say you want to detect people. And there is no single sensor or algorithm that will work 100% of the time and always perfectly, right? So there are always going to be failure cases, and of course you're trying to minimize those.
Yeah.
And one way you can do that is by having different sensors and running different models and combining them together. So let's say that your object detection algorithm was fooled by something which looks similar like a person, right? When you are combining also thermal sensor in the same device, and you have the added benefits of the synchronization and calibration on the device, well, you can directly fuse those results and see that there's no thermal signature coming from that object. So it's likely not a human.
Yeah, that's really cool. So something that just may look to a normal camera that it's a human or whatever, you can, or maybe an engine that's hot or something, you can tell that based on other sensors and other data that's being poured into the system.
And vice versa, right? So maybe some people build their solutions purely on thermal imaging, right? But it makes mistakes in the other way around as well, right?
Yeah, if you think about humans processing the world around them, there's a whole lot of sensory inputs that we have in order to gather information. Right? Exactly, and so we're able to use all of those components, and we describe ourselves as the eyes, ears, and brains of robotics and automated systems, because we can use the context of all of those different sensory inputs to make a smarter decision, as opposed to just take a single 2D frame and say that's a human when it could be a cutout.
That's really cool. I appreciate your guys' time, and Chenik and Jim, thank you guys.
Yeah, thank you so much. Appreciate it.
Yeah, thank you.
Thanks as well.
Here at the show, we see lots of cobots. Cobots are a big thing, robots in general, and a lot of assembly, a lot of different applications here at the show. But what do we do with the more technical applications that require human assembly, and how do we improve those processes, both from a quality perspective and an efficiency perspective? I'm here at the LightGuide booth, and Eric is going to tell us a little bit about how their solution may help with that.
Thanks, Colin. So LightGuide is a projected-based work instruction for manual assembly, repair, disassembly, and all kinds of manufacturing. With LightGuide, we integrate directly with kind of third-party hardware, but projectors, 3D sensors, machine vision, torque tools, MES, plant floor, shop floor systems, in a way to get the correct information to the operator at the right time. So one thing we were talking about a moment ago is the ability for LightGuide to not only highlight the areas where the operator is working in an efficient manner, but maybe also guide them through different locations to pick things, place things, run wires and things like that. But also it's tracking all of the information on the backside. So how long did the overall process take? Were there any errors or problems along the way? And then you can use that and push all of that data back out to a SQL database or a server situation where they can then look at things analytically to make changes.
For sure. And one of the things that we were talking about just before we started recording was some of those applications where having a robot route this wire through this passageway and connect it here and make sure it's seated properly in this location, and then all of that, can be actually a pretty challenging thing to do with a cobot or with an industrial robot or even just some other solution. And that's where humans are still required. We still need humans to perform those tasks. So maybe, do you have any other examples where that is the case, where people, what are some big
I know that we've made
other than maybe routing wires?
Exactly. No, I know that we've made like leaps and bounds as far as accuracy and sensors and dexterity in robots, but there are still certain things that it just makes more sense to have someone follow a step. And even if they're doing the same step over and over again, if a change comes down the line, they can easily adapt and move on. So LightGuide is a way of guiding that correct process every single time. Also stopping people from doing things out of process. So the example I gave earlier is if I have a torque tool, LightGuide will actually engage that torque tool in the time that it needs. I can't go out of process because it's easy for me to do so. So it keeps people from doing things the wrong way by actually forcing them into doing it the right way the first time.
Right, so you're getting actually out of the operator, you're getting higher quality parts, less rejects, more efficiency. So that's very cool. Absolutely. Well, I appreciate your time, Eric. Thanks for sharing with us your technology, and good luck to you guys at the show.
Thank you. Thank you.
I'm here with Chris at Nexus Intelligence, and they're doing something pretty cool here, helping controls engineers write software. And I'll let Chris explain a little bit what they're doing and some of the cool technology here.
Thanks, Colin. My name's Chris. I'm the founder of Nexus Intelligence. We're a software startup building AI co-pilots for industrial automation. We're taking best-in-class models and tuning them to better understand ladder logic, structured text, and other IEC 61131 languages. And then we're integrating the extension that you see here from Visual Studio Code into each of the platform-specific vendor tools that controls engineers use. Our goal is to build a really seamless workflow for controls engineers at manufacturers, system integrators, and OEMs to build projects more efficiently and ultimately deliver projects faster.
Yeah, I think it's really cool. You showed me a demo earlier, and asking and prompting the co-pilot, different questions, and it's answering them or adjusting the code. Tell me a little bit more about how that works and that interaction that's happening. What are some of the tools there that you're providing?
Yeah, well, a lot of people in the last couple of years have become pretty familiar with AI co-pilots through tools like GitHub Copilot and Cursor. And our main message is that software engineers have, to date, gotten the best tools because they're building tools for themselves. But a lot of the best tools from software engineering haven't come over to the world of industrial automation. So what we're doing is we're taking the models and methods from software engineering and we're applying them and integrating them into the tools that controls engineers use every day. So we're helping controls engineers explain existing code. For example, if you've got a ladder program that doesn't have any comments on the rungs, you're hard pressed to understand what's going on. You can ask the model to explain it. You can make changes to existing code. You can write tests for routines that you've developed so that you know that they're working correctly. And then when you're done, you can export all of those changes directly to your existing controls platform so that you can either run it on your emulator, your test hardware, and when you're ready, deploy it directly to production.
Yeah, that's really cool. I know sometimes in the controls space, we're asked, or other companies are asked to help provide support on another machine that someone else wrote code, or even someone internally has now left the company and moved on to other things, and they write it one way and someone else writes code a different way.
Right.
This would be an awesome tool to just dump that in and help me understand how this person wrote this code, so that I can debug or retrofit or something in that industrial setting.
Absolutely, and we support our customers bringing in their own control narratives, their own control standards to help tune the model, better understand code, and generate code according to their own standards. So our goal is just to build the best tools to help controls engineers do their jobs better, and that's kind of what we're about.
Yeah.
So if you're interested in learning more, come visit our website at getnexus.ai or reach out to us by email at hello@getnexus.ai, and we'd be happy to answer more of your questions.
Awesome. Thanks, Chris.
Yeah,
Much
thanks,
appreciated.
Colin.
Yeah, enjoy the show.
Thank you. You too.
I'm here at the Beckoff booth at the show, and I have with me Jeff.
Yep, Jeff Johnson.
And they have this pretty cool, unique product that's some pallets that have pretty much unlimited degrees of freedom in a sense in terms of their capability in each axis. So, Jeff, why don't you tell me a little bit about the technology and what it is?
No problem. So this is we call this X-planar, and it's one of our think of it as a transport system, but it's a lot more than just a transport system. So it's based on magnetic levitation. So as you see the movers moving around, they're actually floating above the surface and we have 6 degrees of freedom. So you have 0 to 5 millimeters up and down. You have free XY motion. You can tilt in X, you can tilt in Y, you can also rotate. It's contactless, so there's no mechanical wear, very quiet system, very flexible. So when you think about it, a traditional transport system, what you're going to have is usually you've got like a conveyor or an indexing conveyor or rotary indexer. So everybody indexes a fixed pitch, you do your work, then you index again. So with this, there's no pitch to the system. So the movers can move independently to move different distances. So as you're doing, like say, an assembly application, your stations don't have to be on a fixed pitch. I can have my large station that takes up, like say, a foot of space, and I could have some smaller 6-inch, 8-inch stations. So now you're combining the whole, reducing your footprint and getting maximum throughput. The other benefit of, we have this, it's asynchronous motion, so traditionally your slowest process is what's going to dictate your process time.
Right.
So now with this, I can say, okay, I've got one process my slowest process, maybe I'll have a 4-up station. And then I've got another process that's a little bit slower, that's got a 2-up, and then the rest of my stations are 1-ups. So now, as the machine is flowing, I always have 2 movers ready for the 2-up station. I have 4 movers ready for the 4-up station, and now what you've done, you've maximized your throughput on the machine.
Yeah.
So it's a huge benefit. It's a different way of thinking about it.
Right. It gives you a lot more flexibility when it comes to how am I going to lay out my machine, and how am I going to achieve cycle time and all of those different characteristics.
The other benefit too is traditionally, people, I'm doing high volume on one machine. I have my low volume machines. I do changeovers. Well, with this, you can actually do both high volume and high mix on it. Like right now, we got 6 movers. We're going to assemble 6 different products.
Right.
So each mover can do take a different path through the system.
Right.
So what we're finding is a lot of people, they're designing the system to have different stations. A lot of the processes, the parts have common processes, and then some have unique.
Right.
So now I can run, 3, 4 different parts, and each mover can go to its described stations. It doesn't have to stay in line. It can jump out of line and go.
Yeah, exactly. As an integrator, we see that a lot. Is customers, they want lots of different various, processes for a couple different products, and it can drive cost up when you have to integrate and find different ways to overlay all the different features onto a single pallet, or have to have different pallets, or even maybe a different machine.
Yep.
Whereas this is like much more adaptable and much more universal when it comes to how I lay out my machines.
The other thing is you can take when you look at your tooling at your stations, the other big benefit is we've got this free XY 6 degrees of motion. So now your tooling gets simplified. Say you're building up assembly, now we got to lay say a bead of silicone around. So normally you'd bring it over and you've got this 4-axis system that's going to come down and do the M&G code, lay the glue. Well, in our case, you could have the glue head come down,
It's fixed,
and then now we
right.
do the M&G code we do the path for laying that silicone down. So there's a lot of little things like that where take advantage of this XY motion and make your tooling simpler. So
it's really cool.
Yeah,
really unique technology, and thank you very much for your time. Thank you for showing us.
No problem.
I appreciate it.
Yeah,
Thanks,
thank you.
Jeff.
Yep.
Yeah,
Only limitation is your imagination.
right. Awesome.